Perfect. Thank you. Thank you so much.
No worries.
So
Sam wants
it's
me to tell
recording
you
now.
that his AirPods aren't connecting, so he's trying to like get his audio fixed.
Okay, who's that, Aiden?
Sam Troster.
Okay, thank you.
Ms. Tossner.
Yes, sir.
Harrison Simmons was allowed into the meeting, but it's still giving him the connected screen past like minute. So
I think he just maybe got in, or maybe he logged out and tried to get back in.
Okay.
We'll give him another second. I saw that he was like in there and it was still like waiting for him to be connected. So we'll give him another second. Thank you very much. Let's see who else we're missing. All right. Is Harrison here yet? Or are we still waiting on him? Looks like he's still not able to get in. Okay. All right. So we're going to go ahead and get started. Hopefully whoever was trying to get in can still get in, no additional issues, and we're just going to get going here. Okay, so today we are continuing with talking about trig. Today we're going to talk about something called the unit circle. Quick raise of hands. Did you guys do unit circle at all last year in Algebra 2? So some a little bit. Okay. So most of you look like you've been introduced to it. The way we're going to talk about it, just kind of like a lot of stuff, is going to build on what we talked about yesterday with that Roxy triangle. So if you remember, we drew a triangle yesterday and there were kind of 4 variables drawn on that triangle: an R, a theta, an X, and a Y. So that was what we were calling like our Roxy triangle. Kind of looks like it says Roxy if you read it that way. Looks like Harrison is here hopefully now. Let's see if he was able to get in. We'll give him another second. Okay, so that's where we're going to start today. Let me go ahead and share my screen, and we're going to do a lot of practice with this. Just like we talked about yesterday, it's going to be really important that we work a lot with, radians as we're doing these things. So I know most of you feel way more comfortable with degrees. A lot of what we're going to focus on is radians. If you feel comfortable with degrees, great, and we'll build on that. Okay, so what I'd like you to write down, this is a really important thing for you to know, is that the unit circle is a circle centered at the origin with a radius of 1. That's what the unit circle is. So sometimes we kind of forget about the word unit circle. It just becomes this idea. You know, if you have a unicycle, that's like one wheel. A unit circle, that U and I on there, means that it's a radius of 1. So when we're looking at our Roxy triangle, the radius means this portion here. This R is actually equal to 1. Everywhere on the unit circle, we have an R that's equal to 1. Okay, yesterday we talked about the different relationships between X, Y, and R for our different trig functions. And so cosine was X over R, sine was Y over R, and tangent was Y over X. Well, if we're on our unit circle and R is equal to 1, okay, so this is true everywhere, but on our unit circle, what happens is cosine just becomes the X value. Okay, when we're on our unit circle, cosine is just the X coordinate, really. When we were talking about that triangle living in space, it's really just the X coordinate because R is equal to 1. And the same thing goes for Y. And then tangent doesn't change, tangent's Y over X. And we talked about yesterday that that's really representing the slope of our radius. That's representing the slope of that. Okay, and so this is what's going to be true for our unit circle. We're going to start with some basics, what's called quadrantal angles. It's not super important you know that name. These are our very 4, or I guess technically 5 basic angles. So if I went around and labeled my axes, we would start over here at 0. We would have 90 degrees up here. We'll go with degrees first, and then we'll go back and do radians. So we'd have 0 degrees, 90 degrees, 180 degrees, 270 degrees. And then back here, we have 360 degrees. We talked about a vocab word yesterday. What are 0 and 360 degrees? 360 degrees is what to 0 degrees?
Coterminal angles.
Coterminal, excellent, excellent job. So those are our coterminal angles. They end at the same place. Okay, now if we're doing this in radians, let me go ahead and switch colors here. If we're doing this in radians, we still get 0 radians to start. Now, what we talked about yesterday is if I went all the way around, sometimes that's helpful to go all the way around first, we would get 2 pi. So 0 and 2 pi are also coterminal angles, just with different units. Those units are radians instead. Okay, if I went half of that, so back here at 180, I'd be at pi. Half of that, I'd be at pi over 2. Okay, so each of these quadrants is 90 degrees. And each of these quadrants, therefore, is also equal to a pi over 2 radians. So does anyone know what the radian measure would be down there at 270 degrees? Go ahead and shout it out if you know it.
3 pi over 2.
3 pi over 2.
3 pi over 2.
Exactly right. If you were counting and you went this way, it'd be like 1 pi over 2, 2 pi over 2, which is pi, 3 pi over 2, 4 pi over 2, which is 2 pi. Right? Each of those is a pi over 2. So sometimes it's helpful to count that way. Those are our quadrantal angles. Okay. Now we're going to talk about some additional angles here. Okay. Now I would recommend you drawing this. It doesn't have to be perfect. Also, you'll notice I don't have circles drawn. Technically, there's like a circle around this whole thing. I am not very good at drawing circles, so I just draw the angles. So the lines that are connected here, that's really all you need. So if you want to take a second, draw this. All I drew was my quadrantal, my axes, and then I split each of those in half. So we're going to talk about what's in between those. Okay. So most of you know that this angle, since it's exactly halfway between 0 degrees and 90 degrees, that this would be 45 degrees. So these are our 45-degree reference angles. Okay, now I can go all the way around and count. All I'm doing is adding 45 degrees to each of these things. So if I added 45 degrees to 90, I would have 135 degrees. If I added 45 degrees to 135, I would have 180, which makes sense. That's where we should be. We know that that's already 180. If I add 45 degrees to that, I get 225. Down here, we get 270. Again, we know that one already. And then over here, we're 45 degrees away from 360 degrees. What is the fourth quadrant 45-degree reference angle? Does anyone know?
315.
Perfect, 315. Okay, now you'll notice I said reference angle. These are all our 45-degree reference angle. Can someone tell me what a reference angle is? Do you remember that from yesterday?
The angle measure to the nearest x-axis.
Fantastic job, Josh. So it's the angle measure from the nearest x-axis. So what I'm saying is all of these angle measures from their nearest x-axis, all of those are represented by 45 degrees. They're all 45 degrees away from the nearest x-axis. Okay, so we're going to call those our 45-degree reference angles. Now we're going to go around and do this in radians. And most guys get a little nervous on radians. I think actually counting in radians is easier than adding 45 degrees, and I'll show you how. So we're going to start with 0. And again, we're going to just count in pi over 4s because each of these, just like we added a 45 degrees, we're just going to add a pi over 4. So go with me on this one. Make sure you're paying good attention. So we're going to get 1 pi over 4. Then we're going to get 2 pi over 4. Then we're going to get 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. That took a lot less brain work than counting in 45 degrees, in my opinion, because you're literally just counting to 8. Okay, now we can reduce some of these simplify, right? So our 2 pi over 4, that's the same as pi over 2, so that checks out. That's what we knew that one should be. 4 pi over 4, that's the same as pi, so that checks out. We expected that one. 6 pi over 4, that's the same as 3 pi over 2. We already talked about that with our quadrantal. That's the same. And then 8 pi over 4, that's the same as 2 pi. But if you're just trying to go around and count, it's much easier just to count 1, 2, 3, 4, 5, 6, 7, 8. And then now you have all your angles. It's easier to find, like, where is 5 pi over 4, for example. Okay. All right, let's go on. Any questions on this so far? Hopefully we're feeling good. Okay, now we're going to do some different angles. If you are drawing this all on the same thing, you probably have a line drawn here. Oh, that was not a very good line. And a line drawn here also. Okay, so if you are still drawing this all on the same thing, that's fine. What I'm now dealing with is our 30-degree separations. Okay, these are not all 30-degree reference angles, but they're all separated by 30 degrees. So we're going to go through this one. Again, we're going to start with our degrees, and then we'll go back through and count with our radians, and I'll show you how to do that. Okay, so take a second and draw this. If you want to draw it on a new thing, all I did was split each of these quadrants so that there's like 3 slices of pizza in each of them. Okay, so you're welcome to draw that. It doesn't have to be perfect. I am recording this, and I'll throw this up on YouTube so you guys can rewatch this if this is helpful later. I have a couple other videos I think already up there on unit circles, and there's lots of stuff on the internet as well. Okay, but I think this way of thinking about it and counting this way is helpful. So we're going to start over here with 0, and we're just going to go by 30 degrees this time. So each of these is going to be 30 degrees. Okay, again, up here we have 90, and all I did was split that into 3 pieces. So each of those pieces would represent a 30 degrees. Okay, so we get 30 degrees here, then 60 degrees, 90 degrees up top. All we're doing is adding 30 every time. 120 degrees, 150 degrees, 180 degrees, 210 degrees, 240 degrees, 270, 300, 330, got ahead of myself. And then 360. Okay, now we're going to do the same thing, except this time we're going to count in radians. So remember up here, let's maybe do this in yellow or blue, white. Up here we have pi over 2, and I'm splitting pi over 2 again in like 3 chunks, if you think about that. Okay, so I'm splitting that in 3, meaning I'm taking pi over 2 and dividing it by 3. That's what I'm really doing in that first quadrant. Meaning each of those chunks, each of those pizza slices, if they're 30 degrees, they're also the same as pi over 6. So each of those is a pi over 6. So we start at 0, that's 0 pi over 6. Then 1 pi over 6, we're going to do the same thing we did for our pi over 4. So 2 pi over 6. Let me erase this real quick. We'll come back to that. 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. So again, what's helpful is we like definitely for sure know our quadrantal angles. So they're good check-in places, right? Like over here at 6 pi over 6, if I accidentally got 5 pi over 6, I know I've counted wrong because I know 6 pi over 6 is going to be the same as pi if I reduced that. Okay, same thing down here at 9 pi over 6. We know that that should be equal to 3 pi over 2. That works out. The 12 pi over 6, that's the same as 2 pi. Up here at 3 pi over 6, we already said that that's the same as pi over 2. Now there's some additional ones though, besides our quadrantal angles that we can also reduce. And you'll notice the ones that I'm talking about, this is going to be helpful for what we do later. The ones I'm talking about are the steeper angles here. So these angles up here are all steeper angles, and those ones can also be reduced. Okay, so the flatter ones over here, these ones all are already as reduced as they can be. Kind of our flatter, not as steep ones. But the steep ones can all be reduced as well. So for 2 pi over 6, that's the same as a pi over 3. 4 pi over 6, if I divide both of those things by 2, I get 2 pi over 3. 8 pi over 6, if I divide both of those things by 2, I get 4 pi over 3. And then 10 pi over 6, if I divide both those things by 2, I get 5 pi over 3. Okay, so here's a tricky question. When we did the pi over 4s, all of the angles that we had, that we drew, that were in each of those quadrants, represented a pi over 4 reference angle, or a 45-degree reference angle, depending on the units you're being asked. I have 2 different reference angles here. What is the reference angle of all of those tall angles that I just drew in blue? What is the reference angle of all of those?
Is it 60?
It's 60 degrees, or the same as what if we were talking about radians?
Pi over 3.
Pi over 3, perfect. So each of these is a pi over 3 away from their closest x-axis. This is going to be really helpful when we're trying to think about our unit circle and all of the different values on there. Okay, so each of those is a pi over 3 reference angle. All the ones that could be simplified to something over 3. They're a pi over 3, or 60 degrees, away from the nearest x-axis. We also had these other guys that had something over 6. So we ended up for the flatter ones as something over 6. Can someone tell me the reference angle of all of the things that are over 6?
30 degrees.
30 degrees, or in radians, what would that be equal to?
Pi over 6.
Pi over 6. So those are all our pi over 6 reference angles. These flatter ones are all a reference angle. Again, Josh said that perfectly. The angle measure from the nearest x-axis, those are all pi over 6s. This is going to be really helpful when we're trying to think about our values for our unit circle, because if you understand reference angles, you really just need to know the first quadrant, and that's it. Okay, and then where we are in space. You don't have to memorize all of these different values. Okay, any questions on this so far? You guys are doing great. Okay, so let's talk about that first quadrant. I've been talking about it a lot with our different reference angles. I would like you somewhere kind of big in your notebook to draw this exact screen. So write down first quadrant. Go ahead and draw the angles. Again, this is part of a circle. I'm just too lazy to draw the circle, and I think it looks a little cleaner just drawing the angles themselves. And then go ahead and write those 3 columns. So for those columns, we have theta, cosine of theta, and then sine of theta. So I'll give you a minute to draw all of those. Again, make this pretty big in your notebook. If you get this portion, it's going to make the whole rest of the unit circle so much easier if you can understand this part. And again, if you're thinking of taking calculus next year or physics at some point, this is going to be essential knowledge for you to have. This is not something you're going to be able to look up every single time. You're going to need to really have this ingrained. And like I said, this is going to lead to the rest of the semester and all the stuff we do second semester. This is a really, really, really important topic. So if you have questions as we're going through, make sure you just ask. It's not a problem at all. Okay, I think most of you have this drawn. What I'd like you to do, try to do this without looking back at your notes, is I'd like you to try to label those angles, and we're just going to label them in radians. I think you guys are pretty comfortable with the degrees of that first quadrant. I just want you to label those in terms of their radians. So you should have 5 radian measures shown there. And hint, they might already be on this slide. Okay, so going through, the first angle is 0, and it's not 0 degrees. Again, we're going to just do it in radians. You can show both if you want, but we're just going to do radians for now. So we have 0, pi over 6, pi over 4, pi over 3, and pi over 2. Some guys get really confused because pi over 6 is the same as 30 degrees and pi over 3 is the same as 60 degrees. Like you kind of want the 3's to go together and the 6's to go together. It's important to remember that a 1/6 of something, like pi divided by 6 means 1/6 pi. that's going to definitely be a smaller value than if you have it divided by 3, right? So that means that the pi over 6 is our smaller angle. Now we're going to talk about the different coordinates that we have at each of those places. Okay, so here's what you need to think about. This is from the unit circle, which is a circle with a radius of 1, meaning each of those black lines has a length of 1. Each of those black lines has a length of 1. So if I am down here at 0 for a radian measure of 0, this entire portion, all in X, remember this is in our first quadrant, we're actually in space here, that entire portion is all X, and X would equal 1 and Y would equal 0, right? There's no height to this coordinate that we would be talking about in space. So that coordinate would be represented by 1, 0. Make sure you have that written down. Okay, that coordinate would be 1, 0. Up here at pi over 2, we'll come back and do all the other ones, but the reverse is true. So again, I have a radius of 1. This entire length is 1, but all of that length is all in Y this time. So I don't have any X portion. That coordinate is on the Y-axis, meaning my X value is 0. So that gives me an X value of 0 and a Y value of 1. It's really easy to mess those up. Just think about, like, where is it? Does it have any X value? Does it have any horizontal component? If not, it's all in Y. Or if it doesn't have any vertical component, then it's all in X. Okay, now is where this gets trickier. And this comes from our special triangles. That's where all of this stuff, next stuff that we're going to do is going to come from. But I think it's helpful to understand it visually. So I have an angle here, or I'm sorry, a coordinate here, a dot in space. And if I were to draw the triangle, talking about the ways that we drew the triangle yesterday, I know I need to connect that triangle to the origin, which is already done, and the closest x-axis, which would mean straight down. Okay, so I have this portion connected. Now that forms this triangle here. This triangle here has this x component and this y component. Just looking at that, you should hopefully be able to tell that the x coordinate is longer, right? The y coordinate is not as big and the x coordinate is a lot bigger. Okay, so I have some special values that again come from our special triangles, and those values here, I'm just going to give them to you, are rad 3 over 2 and 1/2. Rad 3 over 2 is a bigger value than rad 1 over 2, right? That's another way to think about 1. It's this radical 1, it's square root of 1. So rad 3 is bigger than rad 1, meaning the x component, which is this one, represented by this length here, it's the bigger x value. So that's very helpful to remember that and to think about it visually. Okay, if we compare that up top here at the pi over 3, if we look at this pi over 3 and we give this a dot at space, and again, we draw our triangle. So we're going to draw that directly down and connect it to the origin. It's already shown there, but I'm just going to highlight like the x component here. You'll notice the y component is now the bigger one here. So I have a bigger y component and my x component is small. If you can understand this visually, this will help you in all of the different quadrants for all of those different angles. So now we have those same measures, but they're switched. We have a smaller x component and we have a larger y component. So that gives me my 1/2 and my rad 3 over 2. Again, these come from special triangles. So most of you learned special triangles with like a rad 3, a 1, and a hypotenuse of 2. We have a hypotenuse of 1. Our radius, this angle measure here, is always equal to 1. So all we did was divide all of those different sides by 2. Because usually I think when you learn special triangles, you learn it with a hypotenuse of 2. So that's where rad 3 over 2 and 1 over 2 comes from. Okay, all right, now we have one left, which is this pi over 4 here. For pi over 4, you'll notice that if I drew my picture correctly, the x and the y component should be exactly the same. I have exactly the same x and y component, which means the coordinates, my x and y, should also be exactly the same. They should both be rad 2 divided by 2. Again, that comes from your unit circle. You might have had rad 2, and 2 on your special triangles. When we have a hypotenuse of 1 instead, which again, unit circle, radius of 1, that's our hypotenuse portion, we get rad 2 divided by 2 for all of those things. Okay. Does everybody understand this visually? Are there any questions on this portion so far? Hopefully this makes sense. Okay, this is also why we're going to get away from SOHCAHTOA, because when we are on 0 or pi over 2, there's not really a triangle anymore. All we have to work with is x, y, and r. And if you go back to what we were talking about earlier, when we are on our unit circle, cosine is really just x. It's just the x coordinate. Sine is really just y. It's just the y coordinate. And then y over x, really what we're talking about there is slope. We're talking about our rise over our run. Okay, so when we're trying to find cosine, given that first quadrant, all we have to figure out is what's the x coordinate. That's all we have to do. So when we're filling this in, cosine of 0, that just means the x coordinate. So 1. It's this value. That's all we have to do. For pi over 6, we should get rad 3 over 2. For pi over 4, it's rad 2 over 2. Pi over 3, we're at 1/2. Pi over 2, we're at 0. If you know those kind of weird special values in there, and you know what's bigger and smaller, and you can imagine that in space, it's much easier to figure out those values. Okay, for sine, we would get the y coordinate, because sine is always y over r, but our r is just 1 on the unit circle. So we get sine of 0 would be the y coordinate there, which is 0. Then 1/2, rad 2 over 2, rad 3 over 2, and positive 1. This page will be very helpful. If you have this drawn correctly, you have all of that information listed. It's going to be helpful to come back and reference, because all of these are going to be our reference angles. We really only have 5 possible reference angles on our whole unit circle. Okay, so all that's going to happen is I might be in a different quadrant, and so x might be negative or y might be negative. But that's all that's going to change. These are always going to be the exact same values you're dealing with. If you know what your reference angle is and you know what quadrant you're in, that will help you find all of the values for the entire unit circle. Okay. All right. Hopefully everybody has this drawn by now. We're going to go on. So I'm drawing this huge unit circle. I don't care if you draw this whole thing. We're just going to kind of pick a couple to talk about first. Okay. So I am going to randomly pick, you can draw this if you want. I'm going to randomly pick this angle over here. Okay, again, I have my first quadrant filled in, just like we just did. So I have my first quadrant filled in. And now I'm just going to randomly pick an angle over there. Can anyone tell me what the reference angle of that would be? What would be my reference angle?
30.
30 degrees. How about in radians? What would it be?
Pi over 6.
Pi over 6, right? The flatter one, the one that's closer, is pi over 6. So I know I have a pi over 6 reference angle. If I wanted to figure out what angle that was, I can look at my closest x-axis. This over here is pi, and we can do kind of what we did yesterday. So pi is the same as, in terms of something over 6, 6 pi over 6. So that would make that angle 1 pi over 6 away from 6 pi over 6, but it's less than, making it 5 pi over 6. So that's one way I can find out where that angle is, right? I can identify, oh, it's the pi over 6 reference angle because it's the 30 degrees, okay? And then I can use my x-axis to figure out what that actual angle is by subtracting that reference angle or adding that reference angle, depending on if it's smaller or bigger, okay? Now what's true is I'm gonna have some very similar information to my reference angle in the first quadrant. Now my picture is not perfect, but what should be true is it should be the same exact y value. It's the exact same height, meaning the y is exactly the same. But since I'm in the second quadrant, even though my y value is still positive, my x value, just because I'm in the second quadrant, is going to be negative. But it's going to be negative that exact same value, negative rad 3 over 2. If I asked you for cosine of 5 pi over 6, then it's helpful to just draw the 5 pi over 6 on your unit circle. You don't have to draw all of them and figure out where you are. Okay, you can just start with pi. That's our closest reference angle, or our closest x-axis. you can recognize that the reference angle is pi over 6. And now when we're looking over here, again, we can visualize that triangle. The x is the bigger thing in magnitude, I mean. The x is the longer part. The y is the smaller part. And I'm negative x and positive y. That gives me negative rad 3 over 2 and positive 1/2. Okay, let's pick another random one. Let's pick one over here in the 4th quadrant. I'm going to pick this one here. So the one exactly in between that 0 and that 270 degrees. Okay, or 360 and 270, or 2 pi and 3 pi over 2. Can someone else, maybe someone I haven't heard from today, can someone tell me the reference angle of that angle that I just, or that coordinate that I just drew for that angle? It's the reference
45.
angle. 45 degrees. How about in radians? What would that be? In radians, what's 45 degrees the same as?
Pi over 4.
Pi over 4. So we're at the pi over 4 reference angle. Again, push yourself to try to think about what those radians are. So pi over 4 reference angle, meaning if I drew this here, both my x and my y are going to be the same length. So I have the same length for x and y. So that would give me the rad 2 over 2, rad 2 over 2, except I'm in the 4th quadrant. So in the 4th quadrant, y is negative. So my x stays positive, rad 2 over 2, but my y becomes negative. Negative rad 2 over 2. Okay, so I actually know the cosine and the sine. I know the x and the y coordinates. I haven't even figured out what the angle is yet. So again, my closest x-axis is actually this one over here at 2 pi. What he just said is that this is the pi over 4 reference angle, meaning it's pi over 4 away. So what's helpful is to make that 2 pi into something over 4. I can write it as 8 pi over 4. And now I'm just 1 pi over 4 less than that, which would make this angle what? What would this angle be equal to in terms of radians?
Seven pi
3
over
pi over
4.
4.
7 pi over 4. Again, this is 8 pi over 4. We are 1 pi over 4 away, so that makes it 7 pi over 4. So if I asked you what sine of 7 pi over 4 is, that would just be negative rad 2 over 2. If I asked you what cosine of 7 pi over 4 is, it would just be rad 2 over 2. Let's do one more. Pick one in the 3rd quadrant. So I have this one right here. Again, I am now choosing one that is the steeper one. So I have the one that has a longer y value in magnitude and a shorter x value. Can someone tell me what they think the coordinates of that spot would be? So big X, or I'm sorry, big Y, small x, and I'm in the 3rd quadrant.
Would it be negative 1/2 and then square root 3 over 2?
You're very close, Dylan. What needs to change?
Oh,
since we're in the-
negative.
There
My
we
bad.
go. Yeah, I think you were focused on the values, right?
Yeah,
So
I
exactly
was.
right. So I'm looking at small x, big Y. That gives me the 1/2 for the x, the rad 3 over 2 for the y. I'm in the 3rd quadrant. Both things are negative. Dylan, while we're at you, what do you think is the reference angle for this one?
60.
60 degrees. How about in terms of radians? What would that reference angle be?
Pi over 3.
Perfect. So this is pi over 3 away, right? That's our reference angle, which is our 60 degrees. So if I change this to be 3 pi over 3, what angle would that be, Dylan? So if I'm pi over 3 away from 3 pi over 3, that would give me what?
I'm not sure.
Okay, so I'm at
Yeah,
3 pi over 3 right here. And all I want to do is I want to add 1 pi over 3 to that.
Would it be 4 pi?
Yeah, 4 pi over 3. Perfect. That's all you're doing, 4 pi over 3. So that would be the angle right here, right? It's 1 pi over 3 away from 3 pi over 3, okay, which gives us 4 pi over 3. So that can help you find any angle and any cosine and sine on your entire unit circle.
Miss Toshner,
Yes, sir.
wouldn't that have been 5 pi over 3 though? Because you're at the 60 degree reference angle, so you're Aren't you 2 pi over 3 away?
Nope, we are 2 pi over 6 away. We are 1 pi over 3 away because pi over 6 is the smaller one, right? So that's why it's helpful to think about what is that reference angle. And again, if you come back to this first quadrant, if you can get that first quadrant, what you're going to notice is all of the tall ones are all pi over 3s. All of the ones that are exactly split in half are all pi over 4s. And all of the flatter ones are all pi over 6s. Okay, so the ones with like the big X and the small y, those are a pi over 6. So all you're doing is like adding 1 pi over 6 or subtracting 1 pi over 6. Or if it's a pi over 4, adding 1 pi over 4 or subtracting a pi over 4, just depending on what quadrant you're in. Okay, good question. I'm glad you asked that. I'm sure more people had that question. Again, that first quadrant gives you so much information that you need. So let's go on. We're going to try to find some other values here. Okay. So it says find the exact, I think someone's still unmuted, might be you, Josh. Find the exact value of each trigonometric function. So this says cosine of 5 pi over 6. Here's what I want us to do. If you guys remember how we came up with our reference angles yesterday, we didn't draw the whole unit circle. What we did was we started with, and please do this in your notes right now. Okay, we started just with an X and a Y axis. I labeled just the x-axes, 0, pi, and 2 pi. Now, since what I'm looking for is 5 pi over 6, I then went and changed these. So 0 stays 0, pi becomes 6 pi over 6, and 2 pi becomes 12 pi over 6. So my question is, which are we closest to? Well, we're clearly closest to 6 pi over 6, and I would be 1 pi over 6 away. So here's where this is important. You need to remember that pi over 6 is the flatter one. Pi over 6 is the flatter one. Pi over 6 is like the 30 degrees, meaning I'm in the second quadrant and I'm at the flatter one. Okay, so I'm at pi over 6 away from 5 pi over 6. That gives me 5 pi over 6 right here. Now, if I draw my triangle, I can clearly see, well, I've got the big X and the small y there. Okay, maybe I should use my little spinner app, call on someone. Let's see how we're doing. I tried to give you guys a break and just let you volunteer, but I'm going to call on someone now. Let's go to Jorge. Jorge, what do you think is the X and Y coordinate for this 5 pi over 6? What would be my X and Y coordinate there?
It would be, oh, crap, I'm lost.
That's okay. So Jorge, look, I have a big X and I have a small Y. So when we were looking at big X and small Y, that's our like pi over 6, right? We have a big X and a small Y.
Oh, okay.
Okay, but
So
I'm in the second quadrant, remember?
So it'd be negative radical 3 over 2, comma radical 1. Well, it should be 1 over 2.
Yeah, and radical 1 over 2 is fine, but it simplifies to 1 over 2. Perfect. Okay, Jorge, we're staying with you. So if I'm asking you specifically for cosine of 5 pi over 6, which of those coordinates am I looking at?
The x value.
The X value. So what's the X value there?
Negative 3 over 2.
Negative rad 3 over 2. Perfect. So that is what cosine of 5 pi over 6 is. Okay, that is our cosine. Fantastic job, Jorge. So some guys get confused when it says find the exact value. They think type that in a calculator and get a decimal. The exact value means leave it in terms of radicals. Okay, so that means this would be your final answer for exact value. When you're typing it in a calculator, you're actually like chopping off some of the decimals if you write that down. So that's not the exact value. Okay, let's do this next one. Sine of 3 pi over 2. So this is a bit trickier. Sine of 3 pi over 2. I'm going to draw, again, the same thing. I'm going to have 0, pi, and 2 pi. I'm going to change these all to be something over 2 because that's my fraction. So I have 2 pi over 2, and then over here I would have 4 pi over 2. So some of you are already seeing why this is a little bit trickier. Okay. Why is it a little bit trickier, Justin Kruger? Or maybe it's not. Maybe you know exactly where that angle is. Which one is it closest to?
Well, it's the, what's it called? It's the 45-degree, like, in the third quadrant. Like,
So
okay,
you
never
think
mind.
it's this one?
Yes.
So
yeah,
again,
exactly.
so I have 3 pi over 2. And when I look at my x-axes, they're 2 pi over 2 and 4 pi over 2. Where is 3 pi over 2?
Oh, that's, what's it called? It's straight down.
Straight down. It's exactly in between them, right? So it's not closer
Yeah.
to either of them. I think you were thinking about a pi over 4 or something like that. Okay, but be
Yeah.
careful. Actually think through it this way. So 2 pi over 2, 4 pi over 2, 3 pi over 2 is exactly in the middle. So this one would be 3 pi over 2. Okay, so now we've got to think, well, that's my like pi over 2 reference angle. What you'll notice is all of that, there's no real triangle there. There's no way to do SOHCAHTOA. I don't have a triangle. We have to think about it in terms of X, Y, and R. My R value is 1, right? Justin, what do you think the coordinates of this spot are?
0, -1.
0 and -1. So if I'm asking you for sine of 3 pi over 2, which is the coordinate that I care about there?
-1.
I care about the -1. I care about the y value. Sine goes with y, cosine goes with x. Okay, now we're going to get even a little bit trickier. So now we're trying to find tangent of 3 pi over 4. So again, I'm going to start here. Some of you are still trying to think about this in degrees. Some of you are just trying to memorize it, and then you're going to get your angles in the wrong spot. Practice this, because when I pump your brains full of all this other information, you're going to forget all the things that you like memorize. This is a way to figure it out as you go. So again, I'm going to label my x-axes, 0, pi, 2 pi. I have a fraction over 4. I'm going to change everything to be over 4 this time. So 4 pi over 4, and then this 2 pi would become 8 pi over 4. If I want to know which of those 3 pi over 4 is closest to, let's go to Julian. Julian, what's 3 pi over 4 closest to?
45.
Nope, you're not listening. Here are our 3 options: 0, 4 pi over 4, 8 pi over 4. Which of those 3 numbers is it closest?
It's 4 pi over 4.
4 pi over 4. Is it bigger than 4 pi over 4 or smaller than 4 pi over 4?
Smaller.
Smaller by how much?
Pi over 4.
By pi over 4, meaning it's pi over 4 away from 4 pi over 4 in the second quadrant. I expect to see this work. So some of you are clearly still not following my directions. When you take a test next week, you are not going to get credit if I don't see these steps on here. So hopefully you're following along in class today. So 4 pi over 4, you're right, is a 45-degree reference angle, or a 45 or a pi over 4 reference angle, meaning the x and the y are the same value, right? What would your coordinates be up here then, Julian?
Negative root 2 over 2, and then root 2 over 2.
Perfect. So x is negative, y is positive, because we are in the second quadrant. Now, Julian, this one gets a little bit trickier because now I'm asking for tangent. In terms of x, y, and r, tangent is equal to what over what?
Isn't it like y over x?
You're exactly
like
right.
that.
It's y over x. So in this case, you're taking your y coordinate and you're dividing it by your x coordinate, meaning I get fractions within fractions, which are not that fun. I get rad 2 over 2 divided by negative rad 2 over 2. Julian, how would you go about solving this from here?
Don't you have to like rationalize the denominator or something like that? Or
Nope,
is
I
it
have
like
a fraction
the conjugate
divided
like that?
by a fraction. Nope, fraction divided by a fraction. So it's the same as multiplying by the what?
Like the conjugate? Is that
Not the
principal,
conjugate.
or by
Versus the-
itself? But or, I don't know.
Nope, let's go to Landon. Landon, if I have square root of 2 over 2 divided by negative square root of 2 over 2, that's the same as doing what?
Multiplying by the reciprocal.
Multiplying by the reciprocal. So if I have a fraction divided by a fraction, I'm going to take this number, square root of 2 over 2, and I'm going to multiply it by the reciprocal, meaning I flip that other one over. So I'm going to multiply it by 2 over negative rad 2. Landon, what do you get when you do that?
You just get, wait a minute. Can you give me a sec?
Sure.
Oh, it's just 1.
You're very close. It's just
Oh, negative 1.
perfect. Okay, now here's the thing. We didn't even need to do all that funny math. I know the x is exactly the same as the y. Okay, meaning when I do my slope, which is all we're doing, I went up and over the same amount, meaning that the magnitude of that, the slope of that line, how flat or steep that is going to be 1, except we know it's a negative slope. So that slope is equal to -1. You can always do it this way. But if you can visualize that slope, especially for like our pi over 4s, our 0, or our pi over 2 reference angles, it's going to be a lot easier to think about. Do you have a question?
Yeah, so we can just like look at it, and since it's a negative slope, we could just say -1, or do we have to like show it?
Yep. Nope. For tangent of any of those pi over 4s, you can totally just write what the slope is. And we're going to eventually learn the slopes of all of them. Okay. If you get stuck, you can show those steps. Yes, go ahead, Josh.
How on the last one on B, how I see how you got like that it's 0, -1 because we're on the y-axis, and that's like the radius. But how did you get that sine would equal -1?
So do you agree that if I am at this spot where I've gone down 1, that my coordinate there would be 0 on the x and -1 on the y? If I've traveled 1 down from the origin, okay?
Yeah.
So what this 1 is our radius. So we've gone 1 down, that's our radius, and that gives us a y value that's negative. Sine of theta is equal to y divided by r, which means we're taking our y coordinate, divided by our r, which is always 1 on the unit circle. Okay. But I can kind of skip this thought process. All I need is the y coordinate.
Right. Okay. So we wouldn't be able to, like there wouldn't be a triangle on the graph.
There's no triangle. Exactly. There's no SOHCAHTOA. That's why we're going to kind of forget about that, because SOHCAHTOA doesn't work at all. There's no opposite or adjacent or anything here.
Okay.
Great question.
Ms. Toshner?
Yes, sir. Good questions,
So
guys. Keep them coming.
For C, we're saying that the slope is -1. So does that mean R is -1?
No. R is the length of this portion. So slope and length are different, right? So our hypotenuse is the length of that, how long it is. The slope is how steep that hypotenuse is. So we're saying the steepness is -1. Okay, let me do a quick example over here. If I asked you for the tangent at 0, and we're saying 0 radians, so I would be right here. Does anyone think they know, without even having to visualize what the coordinates there or what our y are divided by our x are, what the tangent of that would be?
0.
Undefined.
It would be 0. Nope, it would be 0. A flat line has a slope of 0, right? So a flat line has a slope of 0. Can someone tell me where they think I would have a tangent that's undefined? So tangent of something would give me an undefined value. Actually, there's 2 places.
90 and 270? Or
90 and 270
pi
or
over 2
pi over
and
2 and 3 pi over 2. Exactly, right? So if I'm up here at tangent of pi over 2, I get a vertical line. The slope of that is going to be undefined, right? How about over here if I'm at randomly pi over 4? Without thinking about it too much, I've got the same x, the same y, means my rise and my run are the same. The slope of this is positive, meaning tangent of pi over 4 is equal to what?
1.
Perfect. You got it. Okay. We'll deal with the tangents of our 30 degrees and our 60 degrees later. Those generally, it's helpful, at least at this point, to calculate using your y divided by your x, remembering to multiply by the reciprocal. Bunch of stuff cancels out. Okay, we've got a couple more problems. We're going to do some weirder ones here. So we've got cosecant of 7 pi over 6. I bet I'll get through just one more. this is our last slide anyways. Cosecant of 7 pi over 6, I'm going to start the same way. 0, pi, 2 pi. I've got something over 6, so I'm going to change them. 6 pi over 6, 12 pi over 6. 7 pi over 6, that is closest to 6 pi over 6, and it's a pi over 6 away, meaning the flatter triangle. I get a triangle in the third quadrant where my x is bigger and my y is smaller, meaning I have negative rad 3 over 2 for my x, and I have negative 1/2 for my y. Now, cosecant of theta is the reciprocal of sine. So this is like 1 over sine of theta. So sine of 7 pi over 6, if I just asked you the sine, it would just be this y coordinate, right? So if I did cosecant of 7 pi over 6, I'm really doing 1 over negative 1/2. But the easier way to think about that, since it's a fraction, all I have to do is flip that fraction over. So instead of negative 1/2, it's just going to be negative 2 over 1 or negative 2. So you don't have to measure, remember or memorize all the special things for like cosecant. You just have to know what it's the reciprocal of. Since it's the reciprocal of sine, I'm just using the y coordinate. Okay, guys, we're out of time. I'm sure the bell has rung. I apologize for going a little bit over. Fantastic job. Make sure you get going on your homework. I'm going to post this on Google or on YouTube. Feel free to take a look later. Otherwise, have a great day. I'll stay on if anybody has any questions.
Thank you.
See you later. Happy Friday. Be safe. Make good choices this weekend. Mhm.
How did you get -2 from 1 over negative 1/2?
Because if I take 1 divided by negative 1/2, that's same as 1 times the reciprocal of that fraction. So it's the same as 1 times negative 2 over 1.
Oh, okay. 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 All right. Thank you, Mr.
And again, what you can always do, Dane, if it's a fraction and you're doing 1 over, it just means flip the fraction.
Okay. All right. Thank you.
Have a good weekend. See ya.
You too.
Thanks. Dayton, what's up?
So I think it was last week I sent you the email about the test, and maybe it slipped through.
Oh my gosh,
somewhere.
Dayton, I'm so sorry. I totally
no
forgot
worries.
to get back to you. I will take a look at that. I just didn't have a chance to over break. If you saw, I was setting up like thousands of homework assignments. So
Yeah.
I will take a look at that. I'll flag that, write myself a note right now.
Okay,
I will get
thank you
back
so
to you.
much.
Yeah, thanks, Dayton. Have a
Yep.
great weekend.
You as well.